Hey pre-algebra kids, Mrs. again. This is lesson 17 in your pre-algebra book. Today's goal is to write expressions for the perimeters and areas of geometric figures. So we're using what we just learned in lesson 16 and applying it to geometric figures, specifically rectangles and squares. So how do you find the area of a rectangle? Well, that's easy. We know this. Area is equal to base times height. So the area of this rectangle, if we took the base times the height, 8 times 6, we would get 48 centimeters squared. If we were finding the area of the square, we basically square the side length. So 3 squared, because 3 times 3 is 9 centimeters squared. So the area of the square is 9, the area of the rectangle is 48. How could you find the area of the rectangle that isn't included in the square? So let me just show you this, like I'll highlight the area that we're trying to find. We're basically trying to find this yellow area here. So what we'll do is we'll just punch out or subtract the area of the square from the area of the rectangle. So 48 minus, got to change back to my regular pen. 48 minus 9 centimeters squared gives us the area of just the highlighted region, which is 39 centimeters squared. Now that seems easy enough, and when you just have numerical values, it really isn't that difficult, right? But what if we put algebraic expressions into the mix? Oh boy, before you get too stressed out, don't worry, I'll walk you through it. We're going to do lots of examples today. 2a plus 2 and 6, and then 2a's. So let's go ahead and solve this just the same way that we solved the other ones. First, how do we find the area of the entire rectangle? We're going to take the base times the height. So 2a plus 2 times, look at it, 6. This looks just like the previous lesson where we were trying to simplify using number properties algebraic expressions. Well, we just distribute in the 6 like we did in the other chapter. We get 12a plus 12, okay? And then now we can leave it as this new simplified expression for the area. This is equal to the area. 12a plus 12 centimeters squared. That's for the entire rectangle. But we also have the area of the square. The square is just a squared centimeters squared. There's 2 a's and we square them. Multiply them together, you get a squared centimeters squared. That is the area of the square. Now, in order to find the area, again, of the shaded region, which I will shade quickly, basically everything but where that square is, we're going to subtract the area of the entire rectangle minus the area of the square. So when I write this all out in the correct way, I get 12a plus 12 minus a squared. And there really is no good way of rewriting this. You can just leave it like this. This is equal to the, oh, and then we have to add centimeters squared at the end. And this is equal to the area of the shaded region. So not too much more difficult, just confusing because there's a lot of a's. You're probably also wondering, why didn't I put this a with this a? Well, they're not like terms. Remember we had that unit where we talked about like terms. A squared is not the same as a, so we can't put them together. And 12 doesn't have any a, so it can't be put together with anything. So we just leave it the way that it is. All right, moving on. This is the one that you'll have This is just an example. It's not the one that's in your homework, but it's just similar to the one that you'll have in your homework. Notice that there is variables in these as well, and so it's going to be a little bit more difficult. What they want you to do here, and if you're following along with me in the book, we're on work time number 1, is write and simplify an expression for the perimeter of this figure. So we're solving for perimeter this time. Perimeter, remember, is all the sides added together, or 2 times the length plus 2 times the width. But we don't just have one rectangle, we have 2 rectangles, so we need to add them all together to get the perimeter. So we have this length, 8a plus 5, and actually I'm going to do this because I'm going to need a really long, we're going to start up here. 8a plus 5, that's one length. We're going to add 7a, because that's another length. Then we're going to add 5, because that's another length. Then we're going to add 3a. But how do we figure out what those 2 are there? Okay? We're going to have to take this length and subtract this length. So, I'm going to bracket this. We're adding it. 8a plus 5 minus 5. Oops. That's supposed to be a bracket. Move that back to there. Well, I can just make it into a bracket like this. Okay. So, this bracket equals this bracket. Okay? I took this length and I subtracted 5. But I'm leaving my work out right now. Then, we have to do the same thing for this one. So, again, another bracket. 7a minus 3a. This is all equal to the perimeter. Yes, a very, very long, drawn-out thing. And what do we have to do now? Combine like terms and reduce. So what we're going to do, what we're going to start with is getting all the a's on one side and getting all the numbers on one side. So if we do this, we will get, and I might go over some things here, but I can always move it later. 8a plus 7a, where's another a that we have? 3a plus another 8a, because here's an 8a, plus another 7a, because we have one down there, plus, no, not plus, now we're subtracting 3a, so there's all my a's together, all right? Now, after I do this, I'm going to add 5, add another 5, going to, do I add a third 5? Oh yes, because there's a 5 here, there's a 5 there, 5, 5, 5. Add a third 5, and then subtract a final 5. So, right here, if we're just focusing on the 5s for a second, 5 plus 5 plus 5 is 15, minus 5 is 10. So we know we're going to have 10 at the end. Now let's focus on our a's, okay? 8a plus 7a plus 3a plus 8a plus 7a is all going to be 33a. So then we're going to subtract 3 and get 30a. This is the perimeter. Why did I not put 30 and 10 together? Well, the a's are separate than the numbers, so I can't put them together. But this expression equals the perimeter of this problem. Now, that's just the parameter. What about the area? We have to do that as well. So when solving for the area, we take the length times the width, usually. And in order to do this, we're going to have to subtract at the end to get the right one. Because notice that we have this part missing. So this is like our punch out, like our other example where we punched out the square. We're going to punch this out at the end. So first I'm going to take this length and this width and multiply. So we're on area now. 7a times 8a plus 5. That is going to be subtracted from 8a times 3a. Because we're going to take 8a, so this is 8a, and 3a, and subtract them to get the remainder here. So 8a, or not subtract them, but multiply them, and 3a. So that's the area of this. See, 8a times 3a. That's the area of this rectangle. We're subtracting it from the area of the large one to get this remainder added to this one. So when we distribute in 7a, we get 7 times 8, which is 56, a squared, because 2 a's make a squared, plus 35a minus 8 times 3 is 24a squared. These are both a squared, so we can combine them. 56 minus 24 is 32. 32a squared plus 35a centimeters squared is equal to your area. Now that was a lot, and I'm sure you have questions. So I'll meet you on the Zoom, and I can help you through some of these. But this is the basics of what you're going to be doing in the homework with easier numbers, not large numbers like 8 and 7, and less sides. Well, not less sides actually. You'll have the same amount of sides. So again, I'll see you in the Zoom. Bring your questions, and I'll work it through with you.